Hi guys, in this video we are going to resolve this problem. What is the problem? The problem is this one. A DNA molecule, deoxyribonucleic acid, is 2.17 micrometers of length. The ends of the molecule are ionized separately, negative on one side, positive on the other. The helical molecule acts like a spring and is compressed at 1% when it's charged. Determine the effective constant of the flux of the molecule. Okay guys, in this problem we need to remember one formula, one law, that is the Hooke's law. This law acts in the springs or in the elastic, in the elastic materials, or in the springs, and this law is this one. Okay, that is the Hooke's law. We need to use it in this problem. We are going to have two forces, the electrical force and the elastic force that is given by this law. So we are going to have an static balance when we do this operation. We're going to have static balance when we have the elastic force that subtracts the electrical force, and we are going to have 0. So then if we do this operation to obtain the F, to do equal these two terms of the equation, we are going to have this simple equation. We're going to have this, guys. Okay, so like you know, the electrical force is given by this formula. Sorry guys, I have another thing on my copy, on my memory copy. The electrical force is given by this formula. So we have to equal these two formulas, and we're going to have this expression. The program wants that we determine the effective constant of the flux of the molecule. So we need to find this K. If we do, we need to find if we clearance key K, we're going to have this one. This equation, like you know, a molecule have charge, of course, But what is this charge? Well, this charge is the electrons that have the electrons, and we have 2 electrons because the problem says that are ionized separately, negative one side, positive on the other. So we have is E elevated to 2 or E squared between X that multiply R squared, and we need to do one simple operation, that is this. X is this one thing. X is 0.01 that multiplies R because that you know 1% is equivalent to this 0.001, but this is only the 1% of the R. R is this other value. So this is a simple operation to find the 1% of the distance R. Oh my god, I have a problem here, guys. Okay, of the distance R. Micrometers. Okay guys, so if we substitute the X on our formula, we're going to have this. Oh, then we can express K like this, like R, like K that multiplies E squared that divides 0.0100 that multiplies R elevated to 3 . K, guys, K is Coulomb constant, and Coulomb constant is given, okay, okay, sorry. Coulomb constant if we substitute our values, we're going to have this, like you remember, we obtain this. So the K is equal to this value, K that multiplies E squared. What is E? E is the share of the electrons guys. Of the electron. So we have this is the share of the electron squared, of course, like you can see here, between 0.01, that is this value, that multiplies R elevated to 3, and R is 2.17 that multiplies 10 elevated minus 6 because it's micrometer. So if we do this value, so if we do this value on our calculator, we're going to have this result. Yeah, guys. Oh, wait me please, is because I have my word is crashed. Okay, so we're going to have this value. Another thing that we need to do before we finish is that we need to do the dimensional analysis. Oh, another time I have crashed my Windows, my Word, sorry. The dimensional analysis, guys. Okay, this is very important because we're going to work with the units that we are going to obtain. We have neuron that multiplies meter square between colon square that multiplies colon square between meter elevated to 3, like you can see here. Neuron meter square between colon square is because this is the units of the k of the colon constant This value you can search on Google and you are going to obtain this value. You can obtain two that is 8.99, but for me it's more easy to work with this value, that because 8.99 is equal or very similar to this one. So you can search colon constant on Google and you are going to obtain this value. The same for the charge of the electron. Okay, guys. So we have these units, and if we do this multiplication, the colon are going to cancel because it's the same, and like you know, we multiply first this and divide between c squared, sorry. We're going to have only neuron in the numerator, and in denominator we're going to have meter. So we're going to have this one. This is the units for the constant. Okay, guys, I finished. This is a very easy problem, easy problem. If you have one question, you can ask me. I want like you understand all, like you do your homeworks and do everything at 100%, guys. Okay, guys, if you like this video, you can share it, you can like it. This is all. Thank you so much.